Aloha everybody. So this video is going to give you an introduction to solving by substitution. So substitution is one of our three methods that we have for solving a 2 by 2 system of equations. So 2 by 2 meaning two equations, two unknowns. So I always like to start out by labeling my equations. This is equation 1, this is equation 2. That way we can talk about them when we get there. So starting off the bat here, here are the steps. And this is a skill, so this is something that we're gonna keep hitting hard and practicing, drill and spill. So steps: solve either equation for a variable. So that means take an equation, pick one, and get a variable alone, pick one, x or y, in equation 1 or 2. And this method is awesome if you have a coefficient, which is the number in front of 1 or -1. That will always make your life easier, and that will help reduce um, the seeing of fractions. So for example, the number in front of this x right here is a 1. So that would be a perfect one to pick. Whereas the number in front of y is a -3. Not that great. This has a -4 in front of the x. Not awesome. This has a, look at that, a 1. So I would pick either equation 1, solve it for x, or pick equation 2, solve it for y. I'm just going to delete that real fast. So get an equation alone, substitute it into the other equation. So that's the key word here, is that you have to make sure that you're going into the other equation. If you plug it into itself, the equation is going to blow up. So you always have to take one and put it into the other. That's what substitution is all about. Once you do that, you'll have just one variable left, so you have to combine like terms and solve for that variable. Once you find what that variable is, then you can plug it into either equation. So here it doesn't matter either. There doesn't matter either. The only time is when you substitute, that's what's important there. So once you find that value, you're going to plug it in and figure out what the last variable is. And then, of course, you should always chickadee check. So solve, solve sub. That's kind of the steps here. Double motion. So I'm going to go here and kind of work out the steps for this problem, and then I'll have you guys try one on your own, and I'll give you the solution for that as well. So I'm just going to start with this. I'm going to take equation 1, and I'm going to solve it for x. That says solve for x. So when I'm looking at x minus 3y equals -2, solving for a variable means you want to get that variable alone by itself. So I want to get rid of this 3y. Well, the way you can move things from side to side is with addition or subtraction. So I'm going to add it to both sides. So on the left-hand side, they cancel out to be a 0. See you later. So you're just going to be left with an x equals. Now on the right-hand side, you got -2 plus 3y. Those are not like terms. This is like you owe your friend $2, and this is like you found 3 yellow jackets flying around the sky. So I always like to put them in order with my variables first and then the number second. So this 2 is negative, stays negative back here. 3y is positive, that goes up front. In front, you don't have to put the plus in right there. So we solve this equation for x. X equals 3y minus 2. Now we're going to take that from 1, and we're going to slam it into the other equation. The other equation is equation 2. So what I like to do is I like to kind of do a like a skeleton framework. So equation 2 says -4x plus y equals 19. So this is kind of like my skeleton framework. It's -4x plus y equals 19. But instead of x, what we're going to do is we're going to plug in what x is equal to. X is equal to 3y minus 2. So instead of x, we replace it with a 3y minus 2. What that does is it gives you one equation with only one variable, and that variable is y. Now y is written twice, so you're going to have to do some combining of like terms. But before we can even do any combining of like terms, ooh, a little bit too much there. We have to do distribution. So we're thinking about PEMDAS, parentheses, exponents, multiply, divide, abstract. So we have to get rid of this parenthesis group by distributing that value through. -4 times 3y is a -12y. -4 times a -2, two negatives being multiplied makes a positive. 4 times 2 is 8. So now this is where we can combine like terms. If I look, I got -12y here, and this is like a +1y there. So if you have a -12y and a +1y, that will balance out to be a -11y. And again, there's only one variable now, so this is kind of your step 3, solve for that variable. So I'm going to do that by subtracting 8 on both sides, get my variable alone, getting that term alone first, and then I can get y alone by getting rid of that -11. Right now it's being multiplied if they're sitting next to it, so you undo a multiplication by -11 with a division by -11. Negative 11 over negative 11 becomes a 1. So this is like a 1y equals 11 over negative 11 is negative 1. So we just found one of our variables. So once you find what one of that variable is, now you can plug that into either equation and you can solve for that last missing variable. So you can take y equals negative 1 and plug it into either equation 1 or equation 2. Now, I'm going to always pick the one that's going to be easiest to find the variable that I'm missing. So here I'm missing x. So I'm going to take that, I'm going to plug it right back into equation 1. So we got x minus 3y, but we just discovered that y is the same thing as negative 1 equals negative 2. So make sure that you complete that whole equation, again, kind of doing like your skeleton framework here, and then replace with what you know. I know that y is now negative 1. Negative 3 times negative 1 is positive 3. And if I wanted to get x alone here, all I got to do is subtract that 3 to both sides, and we are rocking and rolling. We're going to get x equals negative 5. So together, these two things, I'm going to choose black here, I guess. These two things come together and they create our point of intersection, right? These two lines, these are two lines, where they intersect is at the point where x is negative 5 and y is negative 1. So make sure you always write your answer in order, so it's x comma y. Now I talked about checking your work. So once you find an answer, you should always check. Again, a solution to a linear equation is a point that is on that line. Otherwise, you plug it in and you make sure that it satisfies that equation, which means it makes a true statement. So I'm going to check that by taking this and we're going to plug it into both equations. So let's start with equation 1. So equation 1 is x minus 3y equals negative 2. X minus 3y equals negative 2. So instead of an x, I'm going to write negative 5. Instead of a y, I'm going to write negative 1. And then we're checking, do we get a true statement? Does that equal negative 2? Well, this is negative 5. Negative 3 times negative 1 is a positive 3. And negative 5 plus 3 is negative 2. Does negative 2 equal negative 2? Certainly it does. Cool beans. So we know that this point, negative 5, negative 1, is a point on that line right there, the equation 1. Now we've got to check to make sure it's a point on equation 2. So we're going to take equation 2 over here. I'm going to write it down, negative 4x plus y equals 19er. And if I'm talking too fast, slow me down and rewind me. And we're going to plug this in. So we're going to check our point to make sure that this is a point that's on that line. So if I replace the x with negative 5 and the y with negative 1, I am checking, do I get, this is a question mark, do I get something that's true? Well, negative 4 times negative 5 is positive 20. Two negatives multiply make a positive. Plus negative 1, well, certainly 20 minus 1 is 19. Does 19 equal 19? Yeah. So what we just did was we checked our work. So for all these problems, when you get an answer, you should check it. And if it checks out that it works for both of them, then you know you got the problem right. You're going to get a green. If you got something wrong, then there's a lot of places to go wrong with negative signs flowing everywhere. You got to go back and check your work. So it's vital. It's crucial that you guys take excellent notes, make it clean and neat and awesome. Now I got to find my next page here. Here we go. So here's another one. So what I would like you to do is I'd like you to pause the video and try this one on your own. So, and then we'll go over the answer just in a minute. So try to pause this, write it down, pause, write it down, pause, write it down, and then we will go through it. All right, I'm going to assume that you paused it and you went through it, you tried it on your own. If you didn't, and you just want to see the solution, here we go. So again, I start by labeling these equation 1 and equation 2, and I'm looking to do a substitution. So I'm going to solve for either equation for a variable. So this has a 2 in front, that's not ideal. This has a 1 in front, that is awesome. This has a 1 in front, that is awesome. This has a negative 2, not great. Again, if I were solving like for this x, I'd have to get rid of the 2 by dividing, and 2 doesn't go into 7 nicely or into 1 nicely, so you're going to get fractions if you don't pick one that has a 1 in front. So I'm going to do it this way, so I'm going to solve, I'm going to solve equation 1 this time for y. So in order to solve it for y, that means I got to try to get y alone by itself. So here we got 2x plus y equals 7. Getting y alone is really nice because all you're doing is subtracting that 2x from both sides. This will cancel out to be 0, leaving you just a y on the left-hand side. And again, I like to put this in order, so it's going to look like negative 2x. And this is a positive 7 sitting there, so negative 2x plus 7. So we started with equation 1. We're going to take that and we're going to slam it into equation 2. So wherever there's a y in equation 2, we're going to be replacing with that jazz. So here's kind of my skeleton framework. I got x minus 2y equals 6. There's my framework, but instead of a y, we are plugging in negative 2x plus 7. Now this leaves me with one equation, and this time I only have x's left. So what we're going to do is we're going to combine all of our like terms together. Start by distributing this negative 2 through. Don't forget the negative, its sign is always in front of it. A negative 2 times a negative 2 is a positive 4x. A negative 2 and a 7 makes a negative 14. These guys I like term. If I have, this is like 1 apple plus 4 apples, that means I got 5 apples here. And I'm on my way. If I want to get x alone, this is solving linear equations. This is like target 1 here. We're going to add 14 to both sides, leaving us with 5x equals 20. And we can get x alone by dividing both sides by a 5. And look at that, x equals 4. That's Brett Favre, the man, the myth, the legend. So now that I got one of my variables solved out, I'm going to plug that into the other into an equation. Doesn't matter here because we're finding a point that should work for both of them. So I'm always going to, so if I got an x, that means I'm going to look for the one that has the y. So this one would be easier to solve for y. So I'm going to plug that into equation 1. So I got 2x, but instead of an x, it's really a 4 plus y equals 7. 2 times 4 is 8. And then lastly, we get rid of that 8 by subtracting it. So the way that we move things from side to side is with addition, subtraction. And we should get negative 1. So putting this answer and that answer together, what we just did was we found where these lines intersect at 4, negative 1. I'll leave it up to you to check to make sure that they work. Replace the x with 4, the y with negative 1, see if you get something true. Replace the x with 4, y with negative 1, see if you get something true. Alright, so that concludes our introduction to this stuff. We are going to be doing more in class next time. Have a stellar week, you guys. Ciao for now.